Hello, my name is Mikko Kangasmaa and I will present the results of my master thesis now, which is titled Activity Tracking Data for Protected Area Visitor Monitoring, a case study of mountain biking using Strava Metro. The thesis is part of the Mobicon project and made with collaboration with Metsähallitus, which is the protected area managing organization in Finland. Some background to the topic. So protected areas are facing increasing recreational use pressure. Visitor numbers are increasing as well as more different activities are being done in these areas. And out of these areas, mountain biking stands out as one of the fastest growing recreational activities in Finland. And efficient management of mountain biking is needed to cope with these increased numbers. And this requires data obtained from visitor monitoring, so we can understand where and when these mountain bikers are moving. And traditional visitor monitoring methods are time and resource intensive, typically conducted using trail counters and visitor surveys. And activity tracking data could complement these traditional practices. My research questions are: what is the relationship between Strava Metro and real mountain biking volume, considering temporal and demographic patterns? What is the spatial distribution of mountain biking activity in the research area? And what trail characteristic most affect the popularity of mountain biking trails? Some highlights from the literature review. So activity tracking data offers a transformative approach to studying cycling and recreation. Before studying these topics was done using surveying or small GPS campaigns, which are limited in both scale and the time they can cover. However, the validation of activity tracking data is restricted by the lack of comparative data, especially in recreational areas, where usually the only quantitative data we have is counter data, and it's limited by the number of counter stations we have. And activity tracking data can have poor representation across socioeconomic groups. So the data only shows a subset of all people, and it's usually biased towards middle-aged men, for example. And finally, quantitative analysis of trail characteristics has been limited by low sample sizes. As I said before, quantitative data in these areas is usually restricted to the counter stations, so that limits the complexity of the analysis we can do. The study area includes 3 national parks in northern Finland: the Pallas-Yllästunturi National Park, Urho Kekkonen National Park, Pyhä National Park. I will refer to these areas as Ylläs, UK, and Pyhä. And these areas were selected because they are among the most popular national parks in northern Finland, as well as popular mountain biking destinations. These areas are characterized by having a lot of elevation differences. So a range of fells goes through each of these national parks, and they include both forested areas and high tundra areas. And most of the mountain biking is concentrated in specific areas of these national parks. In Ylläs, almost all of the official mountain biking trails are in the southern end of the park. In UK, the mountain biking trails are in the west side of the park. And in Pyhä, the mountain biking trails are quite spread out through the national park. And it's to be noticed that Pyhä is considerably smaller than the last 2 areas. Activity tracking platforms. So they are platforms that allow their users to plan, navigate, and record their activities. And the recorded activities can be accessed. many different platforms, but all of them have similar functionality. And the platforms we'll be using in this study are Strava and Ride with GPS. And these activity posts typically include a GNSS track, timestamp, length, pace, and other metrics. And these are social platforms, so users can interact with each other's activity posts and also download each other's GNSS tracks if they want to navigate the same route. The data includes Strava Metro, which is segment counts. So in Strava Metro, individual Strava users' GNSS tracks are aggregated to these kind of segments. So sections of trails, for example. So every time a user's activity track crosses a given segment, they are counted as its value. And then I will be using the counter station data provided by Metsähallitus. It includes 19 counter stations in the research areas. Then Ride with GPS, which is unprocessed GNSS tracks from Ride with GPS users. Auxiliary data, such as digital elevation model, land cover classification, amenities, and difficulty ratings. And then as a validatory method, I conducted expert interviews. Comparison of Strava and counter values, so the validation of Strava data, was done with monthly values between 2021 and 2023. And each Strava segment was spatially joined with the corresponding counters, and their values were compared using Pearson's correlation. Density mapping was used to map the spatial activity of mountain biking, as well as to compare Strava and Ride with GPS data. And density mapping equals aggregating vector lines to a raster surface, which enables we can normalize the data so we can compare them to each other even though their values are significantly different. Data enrichment was done to the Strava data to find which explanatory variables best affect popularity. And these variables include route status, so segments part of official mountain biking routes were marked, trail difficulty ratings were derived from another source, major land cover, mean slope, and mean elevation was derived from raster data for each segment, and Euclidean distance from segment center to amenities such as central areas, cafes and restaurants, and shelters was counted. And also average speed was included in the Strava data. And analysis of this data was done using generalized linear regression. It's a method that allows regression modeling for over-dispersed data. And in the histogram, we can see that most of the Strava counts are concentrated in the lower end, in the 5 to 10 counts, but there are still some segments with even 8,000 counts, making it over-dispersed. Expert interviews were conducted as a supportive method to validate the findings of this study, as well as to get an overall better understanding of the trends behind mountain biking. And it includes 4 staff members from 4 bike rental shops, 2 in Yllästunturi, 1 in UK, and 1 in Pyhä. Then on to the results and discussion. First, we'll look at Strava statistics. So how has Strava's, for example, user base or other metrics changed throughout the years? So the number of e-bikes or the proportion of e-bikes has risen considerably, being 2.6% in 2019 and 20.7% in 2023. And this share in reality is significantly higher when considering all mountain bikers. but Strava is biased towards more sport-focused riders, so not that many of them use e-bikes. The share of female and male riders has stayed more similar, but still risen significantly from 12.6% to 18.6%. And in reality, this is somewhere more close to 50-50 when considering all mountain bikers, according to the visitor surveys. And the age groups have also stayed relatively similar. However, there's been increase in the oldest age groups from 3.1% to 8.5%. The age group which is over 55 years old. So comparison of Strava and counter data shows us that both data sets follow roughly the same temporal distribution throughout the years. However, we can see that in certain months there are more differences. Especially August and September are different when they are compared. In August, we see much higher percentage of Strava values, and in September, we see a higher percentage of counter values. And then some other months, such as October, June, July, are quite similar across the two data sources. And correlation analysis reveals us that in Ylläs, there is a almost perfect correlation with counter and Strava data. In UK, we have a moderate correlation, and in Pyhä, we don't have a significant correlation at all. And in UK, we can see these three dots that are quite high values in Strava, but not that much in counter. And these are likely to be a mountain biking event which is held in August and attracts a lot of sport-focused riders, and most of them use Strava or other similar platforms. And here we can see the percentage of Strava values from the counter values on a monthly level. And what is interesting here is, again, we can see the values of August for UK, which are really high. So, for example, in 2022, almost fourth of Strava, of all mountain bikers use Strava. And this is likely because of the big mountain biking event. Another considerable thing is that in Pyhä, the share of Strava users is considerably lower than in the other two research areas, around 5%. Density mapping reveals us that most of the mountain biking activity is concentrated on these central areas where most of the official trails leave from. And official mountain biking trails get the most volume. However, there are still significant volume in connecting trails and other trails in the national park. But there are no off-trail riding, since the terrain doesn't really allow it. And there are differences between the two datasets. So Strava, being segment counts, its values are restricted to the OpenStreetMap segment. So if there are some trails that are not part of OpenStreetMap, then they are not included in the data at all. And here we can see that in Ride with GPS, there's a lot of these connecting trails between, for example, official mountain biking trails. And these are not included in the Strava data at all. And it is unclear what happens with the Strava activities that go through these trails, since there is activity there, just not included in the data. Regression modeling reveals us that the most significant factor affecting Strava counts is average speed. So for every unit change of average speed, the amount of riders increases by almost 70%. And also, as route difficulty increases, rider numbers decrease by 20%. And average speed and route difficulty are also connected to each other, since increased difficulty often leads to reduced speeds. And after an interaction effect was added to the model, we can see differences between the 3 national parks. The most significant differences were that UK was less affected by average speed than the other 2, as well as less affected by distance to shelters. And Pyhä was significantly affected by average slope. So the steeper the slope, the less riders there were. The most popular land covers for mountain biking were bare land and shallow vegetation. And this is likely because these are elevated areas with nice views and nice landscapes. And also, according to the interviews, many people decide to ride there. Official route status also had a significant effect on the counts. So segments part of official mountain biking routes recorded nearly 10 times more cyclists than ones without, on average. On to the discussion. So Strava reflects temporal changes in real mountain biking volume relatively well. If there is sufficient data, and if these kind of anomalies such as mountain biking effects are taken to account, then it's safe to say that if rider numbers increase somewhere, it is reflected in Strava. And Strava and Ride with GPS both represent spatial distribution of mountain biking. So correlations were consistent between individual counters in each national park, and also interviews supported that all respondents thought that these datasets give a realistic representation to the spatial distribution. And analysis of trail characteristics revealed that the majority of mountain bikers prefer established routes, open landscapes, and easy to moderate difficulty, which allows for faster speeds. However, there are still some problems with the data. So Strava data is sensitive to anomalies. So these kind of events, or even just large group of riders, for example, 10 riders all using Strava, they could disrupt the normal temporal distribution of the counts, especially in areas where there's less data. And Strava's data aggregation to segments can hide details from the spatial behavior of mountain bikers. So if a mountain biker, for example, chooses an unofficial trail, which is not part of OpenStreetMap, then this data is not included in Strava. And Strava's count aggregation can significantly lower its accuracy. So to protect the user privacy, Strava aggregates their counts so that counts under 3 are put to 0, and after that counts are represented in 5 count buckets. And when Strava's share of the total mountain biking volume can be as low as 5%, then these buckets can actually correspond to 100 count buckets in reality. So there can be a trail that has, for example, 100 bikers every month, and in Strava that is rounded to 0. And there is an underrepresentation of casual riders. So there are many casual riders in these research areas using, for example, rental bicycles, and these riders are likely to be not included in Strava data. And rider preferences can be difficult to derive from count data alone. So looking at why people choose specific routes, specific trails, there's a lot of factors behind that, and not everything can be derived from just quantitative data. Future research implications. So we need to understand those generating the data. If we don't understand who the Strava users are, it's difficult to understand the data. And this could be done with a simple survey study. And using many mobile data sources in conjunction, it could reduce bias and it increases data volume, which is a problem in most areas. Large-scale studies across regions or countries. So activity tracking data makes this possible with low resources. We can conduct studies, for example, across entire countries. And collaboration with in-the-field practitioners. It shouldn't be understated of how much knowledge these people have who actually are in the research areas and have experience with recreation and mountain biking, for example. And all of these things show us that mountain biking is changing from a niche sport to a casual outdoor activity. And there can be two groups of riders that are identified: active enthusiasts and casual beginners. And even imperfect data can hold tremendous value. With this data, we can get insights into areas where no visitor monitoring data currently exists or has really ever existed. And finally, sustainable visitor monitoring practices ensure that protected areas remain accessible and enjoyable for all. And as there is a lack of resources, and there seems to be less resources every year for visitor monitoring, it requires the inclusion of new methods. Thank you very much.